This question says, write the enthalpy of formation reaction for liquid water and solid KNO3. So an enthalpy of formation reaction is accomplishing two things. We need to form 1 mole of product from its elements. And remember that the enthalpy of formation of elements is defined as 0. So, two key takeaways here. We need to form 1 mole of the product, and we need to form that product from its elements. So, if we have here water, liquid, this is the product, okay? So, it says liquid water, so we're going to do these separately, and the other one is going to be KNO3 solid. What elements are required to make water? Well, the elements required to make water, not surprisingly, are hydrogen, which happens to be a gas at standard conditions, and oxygen, which happens to be a gas under standard conditions. But here's where it's weird. Normally you would balance this by putting 2 waters and 2 hydrogens. But the enthalpy of formation, which you can look up on tables and will be used in subsequent questions, have to be for 1 mole. The reason for that is we don't want to have to know the stoichiometric relationships for everything that can form from its elements. So we just define everything as 1 mole, and then if we make 2 or use 2, we can just multiply that by 2. So it has to be for forming 1 mole. So something weird can happen here, and it can only happen here. That is, we can use fractional coefficients. For whatever reason, they usually use fractions, not decimal places. So we put 1/2 instead of 0.5. So 2 H's, half of an O2, we get an O. So form 1 mole of product from its elements. The elements are hydrogen and oxygen. The stoichiometric coefficient in front of water is 1. Has to be. Let's do the same thing for KNO3. So here we have KNO3 as a solid. What elements are we going to need to form this? Well, we're going to need K, which happens to be a solid. We're going to need nitrogen, which is a diatomic gas. And we're going to need oxygen, which is also a diatomic gas. K is balanced. Remember, we have to form 1 mole of this. We have the elements, but we have to form one of these. We can use fractions. In this case, 1K, 1K, we're good. We don't need N2, we only need one of them. So just like in the previous example, we put 1/2 there. Then for oxygen, we need 3 and we have 2. Again, we don't usually use decimals, so we don't put 1.5. We put 3/2, which is the same thing, for oxygen. So this is how we do enthalpy of formation reactions.